Hi students, let's start with our part 3 video for friction. Today's objective is to identify the factors affecting friction. So here's a cube placed. We know that if we push the object, there is a frictional force acting from this direction. If there is an applied force from this direction, then there is a frictional force in the opposite direction. The force of friction will always oppose the applied force. What are the factors that affect the friction? Let me give you these three situations, and then you will tell me what it depends on. The first situation is when a smooth object is moving on through a smooth surface. The second is a smooth object on a rough surface, or a rough object on a smooth surface. And the third situation is a rough object on a rough surface. In which situation do you think has the highest friction? Yes, it is a third case. Because the force of friction is higher because it's moving on a rough surface. Which has the lowest friction? It is, yes, case 1, that is smooth object on a smooth surface. Even though here in part 2 there is friction, but the friction is less than that of the third case. So we can see the force of friction increases as we go towards the right. So can you tell me the first factor on which the force of friction depends? Yes, it depends on the nature of the surface on which the object moves. And the nature of the surface of the object, yes, the roughness of and smoothness of two objects. If you want to find out if it's true, here's what you can do at home. Create an inclined slope on the table and mark a point somewhere on it. Now, from this point, a small cylinder-shaped object moves downwards. You can see after some point it stops. Now, take a sandpaper, place it here, and draw a cylinder down. You can see the distance covered by the object in the second case is less, and you probably know why. The surface on which the object rolled was rougher in the second case, and clearly the force of friction was more. Why is friction caused though? It is caused due to irregularities on the surface in contact. What do I mean by irregularities? Now, even though the table looks smooth, if we zoom into the surface, we will see the surface irregularities. Even the surface of the object has minor irregularities. Now, the irregularities on the surfaces lock into one another. So, whenever we have to move the object, we need to overcome the irregularity. But why the friction is higher on rough surfaces? It's because the rough surfaces has more irregularities. And if the irregularities are more, the force will be more. So the first factor affecting the friction is the nature of surfaces. Is there any other factor that you can think of? Let's say there are two bricks on the table. One is 2 kilogram and the other is 5 kilogram. Now I apply equal force to them towards the right. Which brick do you think will move faster? Both are kept on the same surface and both the bricks are made of the same material. So on applying the force, the lighter box will move faster or move with a larger distance. What does it tell? It tells that the force of friction depends on the force at which the two surfaces are pressed together. Why is that? Because the second brick is greater weight, greater force presses onto the surface, which results the interlocking between the irregularity to be more. As a result, more friction. So basically, there are two factors on which the friction depends: nature of both surface and force to which the